with Scalacheck in a small project. If you look at the build SBT I'm going to start with, it does nothing but import the Scalacheck library. We're going to create a single test. We're going to call it updown.scala, and it's going to be a Scalacheck test. It's going to have a single spec called updown, and it's going to test a single property, which is that up. Then down is the same as down. It's going to take a string as input, and it's going to do just that. It's going to take the string, convert it to uppercase, then to lowercase, and see if that's the same as taking the same string and just converting it to lowercase. Let's go to a shell and try to run our test. You might expect that this test would pass, but actually it will fail often. And the reason it fails is that there are many Unicode characters where two different lowercase characters share the same uppercase character. The interesting thing in the output here I wanted to point out is that we get two different values back when we get a failed test here. We get arg0 original, which is the original test case that failed. And then what it's done is given us an arg0, which is just a single character, which causes the problem for us. It does that by taking our original string and shrinking it into smaller and smaller pieces until it's narrowed it down to a single failing character. Let's play around in the console and see how this works. If I import org.scalacheck, I can play with things in implicit scope called shrink instances. There are shrink instances for lots of different values. If you look at the string instance, we can ask it to shrink a string for us. Let's take ASDF. When I run shrink, it's going to give me back a stream. If I force the stream, we can see all the things on the stream. And starting from my ASDF original string, what it's done is it's given me some smaller versions of that same string to try as possible new test cases. If we were to take one of these, if one of those were to fail, it would give me back even smaller and smaller cases until I get an empty string, which when I ask it to shrink the empty string, it's going to tell me, it's going to give me back an empty stream saying I can't shrink that any further. And there are these shrink instances for lots of different types. I can shrink, ints for instance, and I can even shrink tuples of string and int. If I give it a tuple of a string and an int, it will give me a stream of possible new values where it first tries to shrink the string and then it tries to shrink the int. So let's go back to our test case. Here is not the most interesting thing to be testing. What's much more interesting to be testing is if we had people, because people are more interesting than strings. We're going to say that people have names and they have ages. And so we're going to change our test case to, instead of taking strings, to take people. And now we're going to try and shrink their names. I don't mean shrink, I mean convert them from uppercase to lowercase. If I were to try to run my test case here, it's going to fail on me, saying that it doesn't know how to create arbitrary people yet. So that's something we know how to do. We can put in implicit scope a arbitrary person, and we can create that using a for comprehension. People will have arbitrary names, and they'll have arbitrary ages, and that is how you make people. And now I expect that when I try and run my test case again, it will know how to create arbitrary people, and therefore create arbitrary test cases, and I'll find failing test cases. However, in this case, it no longer is giving us back a shrunk version of their name. I get this long string, and it's going to be tough for me to figure out why this big string failed. That's because it does not know how to shrink people, because that's something I just made up. So we can fix that by telling it how to shrink people. by creating an implicit person shrinker, which is going to be of type shrink person. Now I'm going to use a constructor they give us that takes a person as input and returns that stream of shrunken people. But that's not going to be too easy to create but on my own. But knowing that I have a way of shrinking tuples, we should be able to shrink people if we know how to shrink tuples of string and int. Now, how would we do that? So first we'll ask it to shrink a person, but it can't shrink a person. It knows how to shrink a tuple, but I can create a tuple that knows how to shrink out of this by tupling the person by name and by age. Now this is going to give me back a stream of tuples, but I need a stream of people. So I can map the stream, and we can use the person apply method that comes with our case classes as long as I tuple it as well. So now I expect that when I try to run my test case again, I will get failing tests, and now the name is shrunk for me again. So this is great. Now I have much easier failing test cases to work with. However, this is not fun to write. This is something that's a little bit tedious, and it might be tedious to remember how exactly we did it. And so you'd hope that maybe there's some magic to make this happen automatically. And as it turns out, there is. And whenever you're talking about magic that involves case classes and tuples, some of you may guess where we're going to go with this. And that magic often comes from the shapeless library. In this case, we're going to use shapeless Scalacheck, which is part of the shapeless contrib project. And it provides exactly the magic we're looking for in this case. So all I'm going to have to do here is import shapeless.contrib.Scalacheck. And now, if we reload our project and make sure that it still does compile, what I'll be able to find is that now I don't need to create these shrink instances. And in fact, shapeless will know how to just put them into explicit scope for me. And in fact, I can get rid of the arbitrary instance I had to create. Shapeless will know how to create that for me as well. And we'll test, and it creates arbitrary people, which are arbitrarily shrunk. So that's great. And if, however, it's not always going to be the case that you can use the arbitrary stuff that Scalacheck creates for you. You might have to create it yourself. For instance, we might say that people have birthdays. And a birthday is going to take a person and return a new person. And that's going to be by making a copy where the age is increased by 1. So we might test something like this and say that birthdays make you older. And we'll say that person, after they've had a birthday, their age is greater than the person we started with. And if we run this, we'll find that we actually get a failing test case because someone whose age is max int, when we increase it, we actually get min int, and that's not greater than max int. So our test case is failing. However, this is really because this is a bad way of generating arbitrary ages for people. And the point is that if we were to use that's the same code that we're going to get from the shapeless library, which will also fail. So in cases like these, what I'm going to have to do is I'm going to have to create the generators myself, which create more reasonable people. And reasonable people only live to be 300 years old. And now my test case will fail. So the magic is nice when you can use it. You won't always be able to use it for a lot, but for a lot of the cases that you're going to generate, you'll find that Scalacheck is able to do a lot of the stuff for you, which makes writing these tests a lot more pleasant and a lot easier.